Here we have a table of observation of for 15 trials of a spinner experiment. The event R red is 2. So that will be the event. Okay. So event R is that is getting a red color on spinning. Okay, and event B, that is getting a blue, right, on spinning. So P of E, so P of E is equal to the number of times of event occurs, okay, of times the event occurs by the total number of trials, okay, the total number of trials. Okay, so P of ER will be 2 by 15, okay, and P of B will be 5 by 15, or we can write this as 1 by 3. So tossing a coin is a very basic but a quite useful example in probability. The possible outcomes are heads and tails. Both have equal chances of occurrence. We have a special name for such an example, that is equally likely events. So the outcomes of an experiment are called equally likely if all of them have the same chance of occurring. Okay, so throwing a dice, the outcomes will be 1, outcomes will be 1, 2, 3, 4, 5, 6, yeah, are equally likely. So to find the probability of an event using theoretical probability, it is not required to conduct an experiment. Instead of that, we should know about the situation to find the probability of an event occurring. Okay. Let us have a look at another problem now. A bag contains one blue ball, one red ball, and one yellow ball. Okay. Now all the balls being of same size. Okay. Um, Kirti takes a ball uh, out of takes out a ball from the bag without looking into it. So what is the probability? Okay. So what is the probability that she takes out uh, yellow ball, blue ball, and red ball. Okay, so let us see the solution for this. Okay, so the experiment is to take all out a ball from the bag without looking into it. So we need to find the probability of three different events. Let us label each even with the initial of the colored ball. Okay, so given is that a ball contains one red ball, one blue ball, and yellow ball. Okay, so let us solve this. Okay, so we need to find the probability of uh, that is yellow ball, blue ball, and red ball. Okay. So since the total number of balls in the total number of balls is 3, so we get the probability of drawing a yellow ball as 1/3. Okay, 1/3. And similarly, the probability of a red or blue ball would also be equal to 1/3. Yeah. So that is P of B will be 1/3. P of R is 1/3. Yeah. An event having only one outcome of the experiment is called an elementary event. So, for example, getting a head or tail on tossing of coin. Yeah. We found the probability of event Y, R, and B. We also learned that such events with one favorable outcome are termed as elementary events. Okay. Now, probability of Y is equal to probability of R is equal to probability of B, which is 1/3. The sum of the probabilities of the events Y, R, B is 1. Okay, and also tossing a coin, event H is head, event T is tail. So probability of H is equal to probability of T, which is 1/2, and the sum will be 1. So the sum of probabilities of all the elementary events of an experiment is 1. So let us have a look at another problem. Suppose we throw a dice once. Okay, so what is the probability of getting a number greater than 3? Okay, so let us assume the event as E. Okay, so the favorable outcome of outcome as per the event E will be, that is, we know that throwing it dies once. Okay, event getting a number greater than 3. So possible outcomes will be, that is 1, 2, 3, 4, 5, 6. Okay, favorable outcomes greater than 3, which are 4, 5, 6. Okay, so the probability of the event P of E will be number of favorable outcomes, that is 3, and number of total possible outcomes, that is 6. So that is by 2. Now suppose we throw a dice once. Okay, what is the probability of getting a number less than or equal to 4? Okay, so let us see this. So throwing a dice once, okay, event getting a number less than or equal to 4. So possible outcomes are 1, 2, 3, 4, 5, 6. Okay, and favorable outcomes less than or equal to 4. So we have 1, 2, 3, and 4. So probability of E event is equal to 4 by 6, or this is 2 by 3. Now let us consider another problem. Suppose we throw a dice once. Okay, what is the probability of getting the number 9? So let the event getting of a number 8 be E. Possible outcomes, which are 1, 2, 3, 4, 5, and 6. Okay, so number of possible outcomes, which is 6. So since no face of the dice is marked as 9, so there is no favorable outcomes. So number of favorable outcomes is 0. Yeah. So we have a special name for the events with 0 possibility. Yeah. So that is the impossible event. The probability of an event which is impossible to occur is 0. Such an event is called impossible event. Now, suppose we throw a dice once. Okay. What is the probability of getting a number less than 7? Okay, let's find this. So let the event getting a number less than 7 be E, and possible outcomes, yeah, which is 1, 2, 3, 4, 5, 6. Number of possible outcomes, which is 6. Since the faces of the dice are marked with numbers from 1 to 6, it is sure that the outcome is always less than 7. So number of favorable outcomes will be 6. Will be 6. So P of E, which is equal to number of favorable outcomes by number of total possible outcomes, that is 6 by 6, which is equal to 1. So we have a special name for event having probability as 1. That is the probability of an event which is sure or certain to occur is 1. Such an event is called sure event or certain event.